Hello everyone. So today we are going to solve another interesting problem number 169 majority element, and it says that we have been given an array nums of size n, and they want us to return the majority element. And the definition of majority element is said in the problem. The majority element is the element that appear more than the floor of n by 2 times. You may assume that the majority element always exists in the array. So just by looking at the problem, the first approach using which I can solve this is what I would do is I will just create one hash map of the array nums in which I will count that what is the count of every number element in the array. So for first it would be 3 has appeared 2 times and 2 has appeared 1 time, and then I'm going to just traverse this hash map and keep keep a check of values in the dictionary, that when my frequency or value is more than the size and is size of the nums array, and if it is more than the size, then we'll return that element from the uh, dictionary that we just created. So we'll return the key in the hash map that we have created right now. So this would be the approach one. But the another thing that the problem is saying, that it is asking that whether we could solve the problem in linear time and O1 of space. So that is the approach two, in which what we are going to do is what we are going to apply the Murray voting algorithm. And this what this algorithm is says that we can solve this problem in two passes. In the first pass, what we'll do is we'll generate one candidate value, and in the second pass we'll compute the in the first pass we'll create the candidate value, and in the second pass what we'll do is we'll just simply frequency compute the frequency of the candidate value that we have created in the first pass to confirm whether it's a majority element or not. And so in the approach 2, this problem would be solved in O of n time complexity, and the space complexity that we are going to use is O of 1. And in the first approach, since we have created a hash map, that that approach has a time complexity of O of n and the space complexity of O of n as well. So now I'm going to write these both approaches one by one and see how we'll solve this problem. So we are going to need the algorithm that I discussed on the side. So I'll bring it little over here. And so first I'm writing the approach one. So approach one appears like this. This is the approach one of hash map. And so what we'll do is we'll just create one hash map at the first. We'll say for we need to create one dictionary. So we'll declare the elements in the dictionary of majority elements. So this would be the majority dictionary, majority elements dictionary. That would be, I'll use the counter from the collections to create the hash map, and we'll need the size. So that is nothing but from the math operator we'll import the seal function that will give us the upper limit of the input array that we have. And now we are going to traverse this with key value in the majority dictionary dot items. This would give us the value with the check that we are looking for. So if the value is more than the size, it means that this element is in majority in the array and we want to return the key of this value which is in abundance. So now let's run our solution and see how it performs. So it has been accepted, and let's run it for all the example test cases and see it how it performs over there. So it has been accepted over there as well, and now let's submit our solution and see how it's performed for all the test cases. So it is faster than 100% of the Python solution. So this is the very good approach which is intuitive, and the Buri's More algorithm is the advanced version of this problem of solving. So now I'm going to write that solution. So what we'll do is we'll create one candidate. So the candidate solution will be inside the variable candidate that I have created, and we'll need one counter to keep a count of the candidate. So we'll traverse the array for nums for number in for numbers in nums. We'll see that if the count of this candidate is 0, then we'll assign the candidate the current and we'll update the count of this number. So the candidate becomes the number that we are having and the count of that number is 1 because we are seeing it for the very first time now. Otherwise, we just want to update the count value with 1 if the majority candidate is equals to the number that we have seen, else we'll decrement it by 1. And in the end, we'll just simply return our candidate solution that we have seen. So now let's run our solution for this. So it has also been accepted, and now let's run it for all these test cases that we have. So it has also been accepted and it is really fast than all the Python solutions that have been submitted. So this approach is of time complexity O of n and space complexity is O of 1, because since we are not using any additional spaces. As per said in the problems, can we solve this problem in linear time? Answer is yes. I hope you guys like my solution. Please like and subscribe to the channel. It helps the channel to grow and it helps me to reach out to you directly with new algorithmic concepts that I'm developing along the way. So please like and subscribe to the channel, and thank you, and I will see you in the next one.